Hi, I'm Vanessa at the Research School of Physics at ANU, and today I'm going to talk to you about uncertainties in measurement. Now, every time you make a measurement, it has a finite amount of precision, and each time you do an experiment, it's always going to turn out a little bit different each time. And so as scientists, we not only need to quantify what we're measuring, we also need to quantify the error or uncertainty in that measurement, and that's what we'll go through now. First, let's clarify the scientific use of three words: error, uncertainty, and mistake. Error is the difference between what you measure and the true value of the quantity. The uncertainty in a measurement is your best estimate of the range of values you think the true value will lie within. And mistakes are when you perform a measurement incorrectly. Scientific methods try to minimize the possibility of mistakes as much as possible. We'll discuss each of these terms in more detail in the following material. Now, the first thing we're going to go through is the uncertainties in your measurements. You might recall that Joe measured his height as being 6 ruffs, the height of 6 Scottish Terriers. Now, I don't have Scottish Terriers at home, and I don't think I'd be able to get 6 of them to stand on top of each other. So in my family, we've always measured heights by making the person stand up against a doorframe, resting a ruler on top of their head, marking the doorframe, and then getting out a measuring tape to measure from the floor to the mark. So let's pretend I've just measured my daughter this way, and the number I read off the measuring tape is 139.6 centimetres. The first type of uncertainty in the measurement is dictated by the fineness of the divisions on the ruler. This measuring tape has lines spaced 1 millimetre apart, and at the very best I can read off a measurement to within about half a millimetre. So I should record the height as 139.60 centimetres plus or minus 0.05 centimetres. This specifies the finite precision of your measuring instrument. Now, in general, for measurements using an analog scale, such as a ruler, a dial, or a clock, the uncertainty in the reading is half the smallest division of the scale. But the uncertainty in your reading or recording device is not the only way your measurement might be different from the best or true value, and we'll talk about different types of error next.